Hello, my name's Ralph Shattock. I'm the Regional Market Manager for BG Products and also a trainer for BG University. What I want to do today is talk to you. This is an old problem that we had many years ago, but it's resurfacing, especially in the European market. With the older cars out there and the longer drain intervals that they're running into with oil, we have to find a way to keep that compression running properly in those vehicles and keep your oil pressure good. So, what I'm going to do is I'm going to use STP oil treatment in the demonstration. They were basically the originators of oil treatments and things like that. So that's why I want to use them and show what is the difference between STP and BG. We've moved ahead a little bit in those years, whereas this has tended to stay exactly where it was before. In these test tubes, I have some battery acid. It's a 4% solution of sulfuric acid. It's just called electrolyte. Okay, so I have this battery acid, about equal quantities in each. I'm going to add about a finger and a half or so of STP to this one. Very hard to gauge a finger and a half because it flows so slowly, as will the RF7. And you'll notice it will sit very nicely on top of the oil. Okay, beautiful mess it makes. Okay, and now we do the RF7, and you'll see there is very little difference between the two. And our competition will point out to the fact, look, it's exactly the same as BG, because it looks the same. Okay, we know that's got absolutely nothing to do with it whatsoever, but this is what is pointed out to people. Okay, now we get to the important part. What we want to do is show you the reaction that we have on the metals on a car. If I build up too much acid in there, what is going to happen to the metal and what is going to be the reaction with the oil itself, especially when we have additives like this. So I'm going to drop a bearing into each one. Okay, I want to make sure these are clean because I don't want to cross-contaminate. And I had some on my fingers. Okay, it's better to be careful, safe than sorry. Okay. An engine builds between 2 to 4 pounds of sulfurous and nitrous acid every 2,000 miles of driving. Okay, so it is sulfurous and nitrous acids, not sulfuric. This is a very dilute version of it, okay, but it is still a problem child. Okay, we want to show what the reaction is on the metal, but also on the oil, okay, because it's very easy to demonstrate. Both of these are now sitting there with their coating of oil additive in the acid itself. What I'm going to do is gently add some heat to it, okay, so that we actually heat up, same as you would inside an engine, we heat up the metal surfaces and the fluids that are in there. And I do it gently. I want to get it started. I don't want anything spraying over me. So, of course, as before, I put my glasses on. Once bitten, twice shy on these sort of things. Okay? And I'm going to go just a very gentle heat on it. I'm trying to be as even as I possibly can. Okay, I think that should do. We just used a very gentle little bit of heat to warm it up and do everything like that. Okay, so we have two types of oil additives that we use. MOA, which is for friction modification, and it has all the seal conditioners and everything else in it like that. Plus we have the RF7. And what's happening is we're actually getting a reaction starting off on the STP one, quite vigorous action of the acid etching into the metal surface itself. Okay, you don't want to overheat these when you're doing a demonstration because it can actually cause a problem in our own one as well. If we overheat, it's ridiculous. Okay, but let's take a look at what's going on here. This one is really starting to boil. And we're getting the acid attacking the metal surface on the bearing. Eventually what will happen is this one will really get going. This product in there, the STP, will actually start to form a sludge inside the test tube. When it forms that sludge, that's the way that it stops the compression. It locks your compression rings in place, and then you stop the blow-by, so you increase your compression, but you do it by building sludge in your engine. We like to do it by treating the oil and protecting the metal surfaces at the same time. Okay? And that is the big difference between the two. So what we'll do is we'll cut away and we'll come back to this in a few minutes. I recommend that when you're doing this, you have something else to go to in the meantime to demonstrate another oil additive, such as an MOA, for example. It takes about 4 to 5 minutes. Eventually, if you leave these two test tubes here, this one will be completely ash by the next day. Okay? Nothing left of the metal whatsoever. But obviously you cannot leave these in a shop, because people will pick them up and start tipping them backwards and forwards, and then you end up with acid everywhere. Okay? So I speak again from experience in that. So we've actually been running with this now for about 5 minutes. You can see there is quite a dramatic difference in the heights of these two fluids and the amount of etching that's been taking place in these metal surfaces themselves. The way STP works is basically it uses the polymers that are rejected by Quaker Steak and Pennzoil to make its oil. And a polymer is used to thicken the oil in most instances. It's to increase the viscosity of that oil. So what we're actually doing is we're increasing the viscosity, we're oxidizing it, we're etching into the metal, and we're making a sludge. I'm not going to leave this to its logical conclusion, which will be the metal will have disappeared completely in this test tube. Okay? We're going to just leave it at that. I think you've made your point pretty well when you demonstrate it this way. Use a little bit of heat. As soon as you see some light air bubbles coming out of those bearing surfaces, stop. Okay? And that's it.